find the antiderivative of the cotangent cubed multiplied by the quadrupled cosecant, the first thing you want to do, you want to split the quadrupled cosecant as cosecant squared multiplied by the cosecant squared, right? Because the two powers, when the base is the same, in this case the base is the cosecant, the two powers will add up, right? So they will add up to 4, to the original 4. Then you should realize that the cosecant square x can be expressed as cotangent square x plus 1, right? So you're gonna basically use one cosecant to write it as cotangent square x plus 1. That's what you're gonna do, right? And then what you're gonna have, you're gonna have cotangent raised to the 5th power of x times cosecant square x dx plus cotangent cubed of x multiplied by the cosecant square x dx, right? And this part should make sense to you because using the u substitution, u in this case is going to be cotangent of x, the du is going to be negative cosecant square x dx, right? So the negative du will be precisely the positive cosecant square x dx, right? So you have to have a negative sign in front of each of these integrals, right? So what I'm saying is you're going to have, let's write the first integral because it has a smaller power than the first one, right? Let's write this integral first. What we're going to have is u to the 3rd, and then there's a minus sign, du, that's for this integral. And again, the minus sign is because the du is the minus cosecant square, right? But we need a positive cosecant square x, right? As in each of the original integrals, right? So there has to be a minus du, right? So the minus du, we take out the minus to be in the front of the integral sign, right? So minus integral of u to the 3rd du, and then this integral is again the minus, right? Because plus minus gives you a net minus, so we might as well just write minus, and this is going to be u to the 5th du, right? So in each case the du is satisfied, right, as being negative cosecant square x dx, but since there's no minus originally written, we have to have a minus placed on the outside the integral, right? Because again, negating the du here will negate this negative, will make it positive, in other words, and positive is exactly what you see here, right? So this is going to be your integrals written in terms of the u variable. So now this is easy, right? This is going to be negative 1/4 u to the 4th minus 1/6 u to the 6th plus a constant. And we have to write everything in terms of the original variable, right? So it's going to be minus 1/4. U is equal to cotangent, right? So cotangent quadrupled of x minus 1/6 cotangent raised to the 6th power of x plus a constant, right? So this is your correct antiderivative. Thanks for watching. Hope this was a lot of fun. See you in the next video.